Okay, welcome back to the Dublin Academy of Maths. Now, Leaving Cert Early Level Maths Series 4, and we're on episode 7, paper 1, complex numbers, and it's modulus. Modulus refers to the length of a line. Okay, now we have this point out here, Z2, and we want to find the length of Z2 to the origin. Okay, now before we do that, we need to there's a rule we follow, and that is the length of the line A plus BI, we square root of them and get the square root. Square them and get the square root of them. Okay, so Z2 is equal to this. 4 plus 3, if I read along the line, I can find out what Z2 is. 1, 2, 3, 4. And if I go up 1, 2, 3, that's 4 plus 3i. Now the length of Z2 is equal to the square root of 4 squared plus 3 squared, which is equal to the square root of 16 plus 9 is 25. 5 units. Okay, so Z2, the length of Z2 is 5 units. Okay, now we can get the length of any lines in any parts of this coordinated plane. Okay, on the image and the real axis. Now the next part it says find the length of Z2 or Z1. So Z1 is equal to the Z1, the line is equal to, or the point is equal to, minus 3, there's 2, okay, so that's 2 minus 3i, okay. Now the length of that is going to be the same again, you square 2 squared plus 3 squared, okay, you don't mess with signs, you just take out, it's all positive, okay. So that becomes 2 squared is 4, plus 3 squared is 9, is the square root of 13, okay, so Z1, the length of Z1 is equal to the square root of 13 units. Okay? Now, so there's just a few things they might add in, like prove that or verify that Z1 plus Z2 is less than, for example, less than Z1 plus Z2. Do you understand what I'm saying? So the length of each of them. So you'd have to do Z1 plus Z2 is just, I have to add Z1 and I have to add Z2, and then I have to get the modulus of it. So Z1 is this one here is 2 minus 3i. So it's 2 minus 3i plus Z2, which is 4 plus 3i. Okay? And we know what these are, okay, because we have them over here. We have them here, we have already done these answers here. So now I first of all I add them and then I'll get the lengths of them. Okay, so we've got 2 minus 3i plus 4 plus 3i, and I cancel them. And I've got 2 plus 4 is 6. Now so this is now this, do you understand? Added. Okay, so that's what Z1 and Z2 is equal to, right? Now to get the length of Z1 plus Z2, I have to get the square of it. Do you understand? So the Z1 plus Z2 is equal to the square root of 6 squared, which is 36. The square root of 36 is 6. Okay, so they always cancel. Same with cubes and whatever, quadratic cubes and higher indices. So the answer is 6. So here we go back to the original equation. Is 6 less than Z1? Z1 is root 13 plus root 25. Okay, and you do it on your calculator. This is 5 root 13. You do it on your calculator. Alright, so it would be less than this. Okay, it would be actually. We're just looking at it. So that's everything explained to you here now on these type of messing with Z1s and Z2s. Now they also do a lot of other things to ask you, like prove or verify that Z1 by Z2 is equal to Z1 multiplied by Z2. Okay, so what you're saying is that individually get the modulus out and then multiply them, but it says do the multiplication first and then do the modulus. Okay, so there's a lot of messing with this. Now remember that you can do all over the plane. Now last week I made an error. There was an error on one of this. I changed it to a minus. It was something over 4 and then it was over 2 and it was 4 minus 16 I think, or something like that, over 4. I changed it to a division. Right now it wasn't a division, but anyway, that's my error, and I've seen it, and hopefully you have seen it as well. Okay, now there'll be plenty more to come. You have to accept the fact that we make errors, okay? Now there's nothing else to add to this. I can just go along now and I can show you the questions. Now the questions are, write down the modulus of each, in other words the length of the line, okay? Now if Z1 is equal to 5 plus 3i and Z2 is equal to 2 minus i, we've done this already. Get the modulus of Z1, get the modulus of Z2, add them together, and then get an answer. Then you go on to add these two together, and then whatever answer you get the modulus. And it's the same for here as well, okay? So you just show that that is greater than and that is equal to that, okay? Commutative properties. Right, that's great. Now I hope you do those questions. Now the whole idea is not to look at me and say, oh, I understand what Michael is trying to get at here. I've 50-60%. The whole idea is to sit down and do the question and make your errors. So your brain patterns will know, or your logic will know where, and your brain will know where you're making those errors. Okay, now I can't stress it enough. Thank you. Bye.